This revision series is brought to you by CREORAY.com. Open www.CREORAY.com, then select class 10 and let's revise chapter 2 polynomials and select the concept 5, quadratic polynomials. Let's start. I'll go through only the important things as this is a revision class. So general form of p of x, you know, polynomial ax squared plus bx plus c, and they will have some zeros of the polynomial. Zeros are usually denoted by alpha and beta. What that means is, zero of the polynomial means when you put this alpha instead of x and simplify this expression, you will get 0. So the value of the polynomial on putting alpha equals 0. So alpha and beta will be the two numbers. So those are called zeros of polynomial. See here, a alpha square plus b alpha plus c on simplification will be 0. Similarly, alpha into beta square plus b beta plus c will be 0. Now let's solve some questions on this. But to solve questions, you should know one more property. What is the sum of these zeros, alpha plus beta, and the product, alpha beta? So alpha plus beta, the sum is given by minus b by a, where b is the x coefficient and a is x squared coefficient. Product alpha beta is given as c by a, that is the constant term divided by a, which is x squared coefficient. So remember this general form, ax squared plus bx plus c. So the sum of these alpha plus beta is given by minus b by a, and the product is given by c by a. Now you will require this sum and product relationship while solving questions. And few questions will ask you to write the polynomial when alpha and beta are given to you. So that time you have to use the fact that p of x equals x squared minus the sum of zeros, that is alpha plus beta, times x plus alpha beta, that is product of zeros. So you can remember it as x squared minus sum of zeros times x plus product of zeros. Now this important thing also translates into factors of polynomial. So p of x can be written as some number k, which can be 2, 3, 4, some number k, into x minus alpha into x minus beta. So know that x minus alpha is a factor of p of x, and also x minus beta is a factor of p of x. Now you will require all these things while solving a problem. Some questions will be of 1 mark, some may be of 2 marks. Let's try to solve some questions. So write a quadratic polynomial whose zeros are minus 3 and 4. You see, alpha is minus 3, beta is 4. Can you write the quadratic polynomial? Try it. Here's the solution. Alpha equals minus 3, that is given in the question. Beta is 4. So what is the sum of these two zeros? Alpha plus beta is minus 3 plus 4. On simplification you get 1. Alpha and beta, the product, that is minus 3 into 4, that is minus 12. So you have the sum, you have the product. Then P of x equals x square minus sum of zeros times x plus the product. So just substitute it. X square minus, what is alpha plus beta? It's 1 into x plus, what is alpha beta? It is minus 12. So that's it. Here's your answer. X square minus x minus 12. Okay, one more question. Find the zeros of the quadratic polynomial 2x square plus 14x plus 20 and verify the relationship between the zeros and the coefficients. So look at the question carefully. They have given you a polynomial. This is of the form ax square plus bx plus c. Can you find the zeros? Remember that alpha plus beta is minus b by a, and the product alpha beta is c by a, and the second part involves relationship. So a relationship is alpha plus beta and alpha beta. So let's see the solution. Now see, P of x is 2x square plus 14x plus 20. Now directly you can find out alpha plus beta, that is minus b by a, that is minus 14 by 2, that is minus 7. Okay, and the product is 20 by 2, c by a, 20 by 2, that is 10. Now this will be used during verification, but we still don't know what alpha is and what beta is. So the first part is find the zeros. How do you find the zeros? You will have to split the middle term. Do you remember this splitting the middle term? It has to be done in a specific way. You have to take this 2 of 2x square, then this constant term 20. So 2 into 20 is 40. And factorize this 40 in such a way, only 2 factors you need. When you sum these 2, you should get the middle term, 14. So 4 and 10 gives you the product 40, and also if you sum it, you get the middle term. So let's split the middle term. 2x square, now 14x can be written as 4x and 10x, and this constant term is dropped as it is, plus 20. Now take out the common things, 2x into, so out of these things what remains? X plus 2. It will give you back 2x square plus 4x. This plus as it is, then out of this term take out 10. What's remaining? X plus 2. So if you see, you can again go back 10x plus 20. You will know that you have split the term right when you get these as common. X plus 2 here and x plus 2 here. Then take out x plus 2 on one side and 2x plus 10 on another one. So you can write this as x plus 2 as it is. And this 2x plus 10, you see that 2 is once again common. So take that 2 out and write the remaining part x plus 5 as it is. So this is of the form P of x equals k into x minus alpha into x minus beta. Don't worry about the sign. The sign can be changed. So here alpha is minus 2. Because it is plus, you'll have to write it as x of minus and in brackets minus 2. X minus beta, so it's x plus 5, so it is actually x minus of minus 5. And beta happens to be minus 5. Be careful in this translation. That is x minus alpha. You have x plus 2, so you can do x plus 2 equal to 0 and find x as minus 2. That minus 2 is your alpha. Similarly, x plus 5 is there. In your mind, you can do x plus 5 equal to 0 and x is minus 5. Now you see, what is alpha plus beta? From these two roots, you can find minus 2 plus minus 5 will give you minus 7. And this is where the second part of the question comes in. Verify the relationship. So now first you have factorized and found out what is alpha and beta. And this is what it is by meaning of verify the relationship. So yes, we have verified alpha plus beta. When you do the actual minus 2 plus minus 5, you get minus 7, which is nothing but minus b by a, minus 14 by 2. This is also minus 7. So first relationship is verified. Second one, if you multiply alpha and beta, you get minus 2 into minus 5, that is 10. Is it same as c by a? 20 by 2. Yes, that is also given. So this question has used all the knowledge that was required. See how you have to present the answer. So this is the first part. This is the second. So where you find alpha and beta. The second part is verification. And you may write in the end, hence relationship is verified. That's your answer. Find alpha and beta only if the question is a long answer question. If the question carries only 1 or 2 marks, simply use minus b by a and c by a and write the answer. I will leave you with this question, which is a solved question, but I encourage you to try it yourself. For each of the quadratic polynomials, you are given 1, 2, 3, 4 polynomials are there. Find the sum and product of their zeros, alpha and beta. Note you are not required to find zeros. See, when you have this kind of a statement in the question, don't go by for splitting the middle term or doing anything fancy. Simply use the relation minus b by a for the sum. So in this question, it will be minus 5 by 3. And for the product, 7 by 3, that is c by a. So don't solve the question. Directly use the relationship and write the answer. The answer is given, but I want you to try it. That's all. Until next time, happy studying.